Hi to another TMS WEB Core video. Today we are going to look at charting with data in databases. What is charting? Charting means that you're going to visualize numbers because a picture sometimes says more than 1,000 words or 1,000 tables. This video is part of the school series, which I marked with this wonderful icon of joyful students. That means this video is based on a dataset that has been introduced in a previous video. We also built a server that accesses the data. So please look at the TMS Software TV video stream for the Mark School series. And the videos are in a certain order. So start with number 1. Or if you already feel comfortable building servers, using a dataset that I provided, then you can start right here. Here you see what we already did. The dataset that we used represents all the schools in Lee County, Florida, and we used Google Maps to place all the schools on a map with coordinates given in the dataset. This slide also shows the designed example that uses Bootstrap. Before we used Bootstrap, we built a prototype in Adobe Photoshop, transferred the prototype to Adobe Dreamweaver, and directly imported this into our TMS WEB Core application. The result is a wonderfully designed, fully interactive map based on the Google Maps API, fully integrated in TMS WEB Core, and the application, of course, is based on a TMS XData server that connects to the dataset. And recently, I even switched the dataset from Microsoft SQL to SQLite. So the demo that you see now is with a switched dataset. So this gives you living proof that switching the backend database isn't a thing of the past. It's actually pretty easy. You don't need to change anything because the XData server delivers the same kind of JSON data, which does not depend on the database backend. What this means even more is if you have customers that have SQLite as a database, you have another customer that has a Microsoft SQL database, you have yet another customer that uses Oracle, no problem. Your web application is always going to be the same because with XData you can change the backend. Apologies for this excursion through database backends and front ends and web applications, but I think it's kind of important that you see the big picture that we're using XData for a reason, to keep our application modular and to keep it loosely coupled from all the other technologies. In this tutorial, you'll learn how to visualize the numbers in a Google chart like this. There is also, comparable to the Google Maps API, there is a Google Charts API. And guess what? TMS Web offers yet another set of components that support the Google Charts API. The only thing you might need is a Google API key to use their API. However, for Google Charts, that is not even necessary. So you don't even need an API key to use Google Charts. And the best thing is you don't even have to care about any JavaScript or any special things about these components. TMS provides you with components that work with Delphi objects and classes, so you don't even know that you're working with the Google Charts API. As a second part of the Google Charting video, we are going to add interaction to the video. That means you can select items from the chart, you can click it, and then you get a list of all the schools in that area code with all the drill down numbers. So this is actually an example how to drill down inside of a chart with reporting. This also just uses standard components. It also just uses standard pop-up forms. But as this would increase the length of the video so much, I decided to make it a separate video. So stay tuned for that one as well. However, before we can start with any of this, we need to extend our service because right now, and I show it to you with the service running, here's our server running. That means if I go into Google Chrome that is, localhost Flex, you see that our service right now gives us access to the school's dataset. The school's dataset, we can access the school's dataset using the path schools. Of course, we are not only interested in all the schools, we have operations. For example, we can say filter, you see code completion here, equals zip equals written EQ. This basically means zip equals 33928, and that filters all the schools in a certain zip code. However, we do not have operations like group by. As a lot of Delphi developers are more used to databases, let me give you the same kind of explanation from the database side. So our data table, schools, this is the data that we just saw in the web browser displayed in JSON format. And in a select statement, you have the opportunity to select certain fields. That is also something that you can do in XData with filters. And you also have operations like sum, max, min. What you're not able to do is to group by a certain field. So give me a little bit to make amends to this SQL query. I reduced the number of fields immensely, and you can see that we have the zip code right here. So in SQL, we have many possibilities to get the list of zip codes. But what we can also do is we can group by zip code and then calculate the total number of students in that zip code. And we do that by adding a group by clause, group by zip code. If you do this, you get a failure because you don't have a field that you group by. So what you need to do is you need to change your fields. You change it to zip. You change it to zip. And, well, let me just run it like this. Now we have all the zip codes. And you can add, for example, sum of students, which is the total number of students. So now we have the total number of students in that zip code. And we name it student or total students. So this is what we're all used to. And of course we can add something like order by zip to sort it by the zip code. Some database systems even offer to order it by the aggregate field, so order by total students, descending. Let's see if that works in Microsoft SQL Server. It does not. Oh, I have to add the S. It does. So now we ordered our data table by the total number of students in descending order. This is exactly the kind of query we want to get in XData. Let me show you the result of the web service that we're going to build. So we're going to add a new path to our URL called chart service. This is going to be the service that we're going to implement. And this service is going to have a method which returns a number of records. Records, of course, are going to be serialized as JSON. So this is yet another JSON document. And you can see here after value, we get a list. This is this little array here. We get a list of all the values that we want to return. And you can see that this is actually exactly what we just saw in the database. We have the zip code and we have the total number of students. And I also added a ratio, which gives us the ratio in accordance to the number of schools. So that means like if we have 4,675 total students and we have 7 schools and the zip code of 33901, the ratio is 667 students per school. And we can do that for all the different zip codes. I will not give the SQL statement for this. Everybody who is following this demonstration should be able to build this in SQL without any issues. However, how do we add this kind of service to our XData server? It's actually not that difficult because XData has a wizard for that. So here you see our XData server with a main form, our entity classes, and of course our server container with a database connectivity. We built this in video number 1 of the school series. Now, in order to add a service to our XData server, we can use a different wizard. Choose File, New, Other. Again, we go to the Delphi category and TMS XData, and there you find the item TMS XData Service. As it says, it creates a new TMS XData service inside of your existing TMS XData server. As soon as you click it, it's gonna ask for a service name. So I'm going to add chart. Be aware the service is being added by the wizard. So if you typed chart service, your service would actually be called, and I might stumble a bit, iChart service. We don't want that. So just type the name of the service without the service in the end. Of course, this also means that the wizard does not allow to build any services without the name service in them. It's kind of a restriction, but I think we can all live with it. And options that you have are you can either generate the interface and the implementation of the service in separate units or in the same unit. We're going to leave the default. We want separate units. We don't want any sample methods, and we don't want to use a specific model. So when we click finish, we get two more units, chart service.pass and chart service implementation.pass. First thing you do, very important, save all the files. Because if you don't do it, you might make changes to the file. And if something happened to the IDE, you'll lose the reference to these files. So just save them right now, right away with save all. And then it's going to ask for the file name again. I always add a U to it and I shorten it a bit. I call it uchart service impl. And of course, the other one is going to be the EU chart service.pass. Perfect. After all that, now it's actually the time to implement the service methods, meaning the methods that actually implement what your service is going to do or what information your service is going to deliver. For this, you go into the interface, which first of all defines all the services, the fingerprint of the service methods. And this interface is being used by XData to build the library or the model in order to show what kind of services your web service offers, or to be more precise, iChart service offers. So iChart service is going to be our service that delivers any information that has to do with anything that we need for charting. That's the premise. And after specifying the service in the interface, we'll provide the implementation in the T-chart service. T meaning the actual implementation. That's Delphi notation. So going back here, let's say we have a function, and the function is going to be called get total students zip, meaning I want to get all the students in a certain zip code, and the return value, and this is where it gets tricky. And this is where it gets tricky if you've not worked with generic types so far. We are going to return an object list, and this object list, as you might figure, is a list of objects, and the type of these objects is a T-criteria result. And a T-criteria result is what our database query returns, a certain number of T-criteria results. Why T-criteria? Because let's think of your database as a space of objects with all the possible return values. In this example, all the schools. And you add criteria to this space, and you make the space smaller. So you add criteria, and by adding criteria, you filter out, or you basically get the result that you want. And the criteria can also project or group the information inside of the space. That is why you return a T-criteria result or a number of T-criteria results. I hope this helps a little bit, but you still will have to remember the term. There's no way around it. Let's switch over to the implementation. We copy paste the fingerprint, implementation, paste, and we make this public, and we press Shift-Control-C to implement it. And the IDE messes this up a little bit, but we should still be able to compile. It does. And now, if you run your service, you already should be able to see the service inside of the model. So localhost Flix, model, here's still the database, and going down, 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 here you see the controllers, chart service, get total students zip, and if I call the method localhost Flix, chart service, get total students zip, this page isn't working. Of course it isn't, because we haven't implemented anything yet. So you would think. The problem is, even if I return something, let's say a result equals nil, meaning it's empty, we close our service, we start it again. Now we go back, call it. We still get error 405. And this is because if you look at the model again, and the controller, you see that the name of the service method is getTotalStudentsZip, but the HTTP method is post and not get. What we're doing here in the web browser is a get web request. So how can we change that? We go into the interface, and by default, this name is being added to every method. So by default, every method you define in the interface is going to be a post method. So in order to switch this, you declare this as HTTP GET, and you have to repeat this for every method. Stop the server, start it again, switch over, refresh the model, and here we go. We have the get method. And now we should be able to call it, meaning chart service get total student zip, and there you go. XData returns the nil value, and XData is pretty smart and recognizes, okay, that's nothing, that's empty. So we get a JSON result where the value is always an array of our tuples is empty. So far, so good. Now to the difficult part. This part actually requires a little bit of study time. Looking at the Aurelius manual, and you're like, oh my God, Aurelius? I've not heard that so far. So Aurelius is the object relational mapping system from TMS, and that technology is being used to create queries because Aurelius has a pretty decent query language in Pascal. So what you need to do is you need to look up in the Aurelius documentation the chapter 7, how to write queries. There's no way around this. Sorry, you have to learn which data types to use and also which methods are available in order to retrieve results, filter results, order results, and so on. You will be able to follow this example easily because I typed the query, but I have found out if I wanted to do it myself, because I've seen a couple of presentations by the principal architect of XData, he writes it down pretty easily. And actually, if you do it yourself, you'll catch up pretty quickly, but you just have to get the rhythm of things first. So I try to give you as much information as possible why I type the queries. So the first most important tip, and this is something that's missing so far from the template. So I already added to my chart service implementation users class Aurelius criteria base and system generics collections as the two users classes that you need in order to go on, in order not to get stuck with code completion, not offering you any examples of what you could type. You know, it makes it easier if you have code completion in the beginning. And what also is needed is, of course, our school classes here, our entities. We also need variants. And now the two really tricky ones, and this is really a pain in the neck because the IDE is not able to help us. So if you use data types from these units, the IDE will not be able to help you. There's this refactoring called find unit or find data type. There is, of course, third-party tools that should allow this to happen, but I can only refer to what's in the product. So you need Aurelius criteria dot link u, and you will need Aurelius criteria, here I missed the u, criteria dot projections. These are the two you need, and as soon as you add these, code completion will be pretty comfortable while you build your queries. So let's go into our method, which is result equals so far, and we can really write everything in one line. We already did it in a database with a SQL query, and exactly like the SQL query, we will build now our Aurelius LINQ query. First of all, you need to get to the database. And database in Aurelius terms is the object manager. And XData offers a class for this, the XData operation context, in order to get to these classes. As said before, this is something you simply need to learn. Look it up in the documentation over and over again until it becomes habit, I guess, or to start with something like I create right now. I create a template for you, and you can use this template for your own custom projects. In order to get started, we need a TXData operation context. And now, if I press dot, we get all the possible completions. Current is exactly what we want. Current dot, we want the manager, so get manager, and this is the object manager instance, and this object manager allows us to add criteria to it. So after adding the dot, I'm actually going into the next line, and you see the Delphi IDE is pretty tricky at this point. You need to struggle a little bit with code completion and the sorts. So in order to find or build criteria that are to be found in the object space, we can use the find method. And this method is generic, so it takes a type as that it will be returned, or the data type of the tuples that are going to be returned is tschools. Why tschools? If we go back to our uschool.pass, you see that this is actually the data type of everything that resides in the database. Going back to the implementation, find tschools dot, and now we can call select, and select in theory, or in database theory, select is called projection. So we need to add projections. If you just have one projection, you can use the tProjection type, but we actually want to add several projections. So we need another helper class. So we say select, and after select, we say a tProjections dot projection list. It means we want to specify multiple. Dot add, we have to remove the period here, add, and you see now code completion works perfectly. One of the projections, tProjection dot group, because we want to group by zip, which is the data type, is the data field for the zip code, and we want to rename this field as zip. Might seem strange, but if you group something, the name changes. You surely remember this from using SQL. Now we jump into the next line, add. This is called duck taping, by the way, or duck typing. We can always add another dot to the query, and the Delphi compiler is able to put it all together. So we add another projections dot sum, because we want to have the sum of all the students, again as underscore, because obviously we can't use as a method name, so we have to add the underscore in the framework. This is again Aurelius specific. Add yet another one. Now we add the count, meaning the number of schools in a certain zip code, so count. We count inside of the zip code .s, and we're going to name this a little bit differently. We name this number of schools. And the last field is doing some calculations. We're going to take the students. Yes, we can do that. That's fancy, isn't it? Students.sum. So this is actually the same thing as this. So XData, or Aurelius, not XData. Aurelius has actually a pretty complex syntax where you can do things one way or another way. So sum divided by link u, zip, and we want the count. And this is actually another way to write this. The reason why I use this above here is because we can add the s and rename the fields afterwards. So students becomes total, and we will rename this to as underscore ratio. This ratio is basically how many students go to one school on average. So we need the braces, and now we close this. So this closes the select statement, and we want to order this, dot order by zip code. So we don't want to order by projection or anything. We want to order by a field name, zip, and then we want to list these values. And that's it. This will return a T object list of T criteria result. It's an amazingly complex query at first sight, but it's pretty logical. And the best thing is, why did I get an error? Okay, I have this server still running. Restart, recompile. There you go. Perfect. Why is this so good? You might ask yourself, why not simply write a SQL statement? This is all so complicated. Well, guess what? This is checked by the compiler, meaning the compiler checked this statement. That means during runtime, you won't run into any issues that there's something missing. The only thing you can screw up right here, of course, is the name of these, because these are still strings and you don't have anything that the compiler can check. However, the compiler can check the sanity of your query, so to speak, that you select something order by. If there's some logical error in that, the compiler will catch up on that. This is pretty amazing if you ask me. So compile, done. Of course, many of you will say, hey, C# has this for years and years. Of course it does, but this is a third-party framework and they build it into their database object relational mapper. So I think it's pretty amazing to point out. So going back to the web service as soon as we start it. So it started, we go back and we call it. Guess what? Here it is in zip code 33901. We got 7 schools, 4,675 students, and this is the ratio. So we just implemented our own custom method and an XData service. As said before, I'm going to split this video in two. We now finished the implementation of the service method, and the next video will show you how to use this service method in a TMS WEB Core application in order to retrieve the data for your chart.